Dr. Elmer, thanks so much.
Thank you. I noticed on the TMC website that some things are not filled in there, so I start with a brief introduction. I changed the presentation quite late, actually way too short before, so I didn't practice. I'm not sure how long I'm going to take. Apparently I don't start things before they're stressed because I don't have enough time. So concerning the discussion that there was yesterday about positive stress and negative stress, I'm not sure where this one belongs, but that's how it always works for me and I think for a lot of designers. My heart goes out to older machines that are not infallible, and machines that also don't consider me to be like an idiot-proof driver as modern cars often are. I like machines that I can maintain myself, repair myself, and I like machines that challenge me a little bit. But that's all about the heart, and the mind obviously, working in the university, also plays a huge role. So I started out as a car designer, and this is the design team of the Russian car brand Moskvich around 1990. So this is me. And from there I started to develop, I was relatively pioneering in car design using CAD systems and NURBS modeling. So I soon started to also design processes, because if you change the tools in a design process, you must also change the process itself. From there on, about 15 years ago, I decided, realized that car design should be something much more strategic than how it was being conducted and how it's still being conducted in many places. I would say that of all the design disciplines, car design is the least intelligent one in terms of in-depth discussion about what it's about. There's many books of car design, and basically it's pictures of cars, and then another picture it will say how fast the car can go. That's about the level of depth. My research is on strategic form giving. So that is to be able to negotiate about form with other disciplines, because that's all a designer is doing 40% of his time, negotiating with other disciplines, to be able to negotiate about form in a structured manner and beyond, look, this is really cool. And that is then applied in brand portfolio management in some companies. So if you are, for example, Volkswagen, how do you manage the form of your products for Volkswagen, Audi, Skoda and Seat? How do you make sure that those four brands tell a different story? Because car design is very much about branding. Preaching, I preach in Delft University. So this is an aerial photograph of our university. There's our aula, it's actually a spaceship. This is our library, and industrial design faculty where I belong is actually in the lower right corner, almost not visible. In Delft, I'm responsible for automotive design programs in both the bachelor, which is a minor program, and in the master, where we have a number of electives under the collective name Advanced Automotive Design. But now, I'm looking to rebuild all those programs into what our dean calls, and what I like, is people in transit. Because car design in its own right has no long future ahead of it, has no reason of being in the near future. So we're going to look at that much more holistic. I'll come back to that in a few slides. So this is a sketch I'd like to share. Don't try to read it, it's way too small. But what's important here is that with all the colleagues that I'm trying to devise this strategy for the future, I think it's first important to set out the timeline. So this is the first 5 years, then 2030, 2040. And I've asked all the colleagues that are involved to sort of figure out what on that timeline are going to be the big developments that we have to foresee and that we have to anticipate as a university. Basically, basic strategy forming. And unlike some speakers of yesterday that think there's a direct connection from designer to the artifact that you're supposed to design. For us in Delft, we are always doing context-driven design, because the most important thing is design is human behavior, not the product. The product is only like an instrument to make a certain interaction happening, and the value of that interaction is determined by the context. Basically, the reason of being of a product is determined by the context. So context is always where we start, so that's why this timeline has two levels, the product level and the context level. But before going into the future, it's important, like the previous speaker, to also have a look at the past. So I would like to start there. And this car is a Voisin, and Gabriel Voisin was a French airplane builder, actually the first one in Europe who built a motorized plane, and also the first one who in 1906 built a plane factory. And later Voisin started to also design and build cars with his staff. So if I talk about the context level and reason of being of products, so this is a car, so this is really the dawn of motoring. This is when we were still trying things, when all cars look really, really different. And when we also racing, because that Voisin Laboratoire, as it's called, is a racing car. So this is like 20 years later, and this car is meant for the rich. This is when automobility became bigger, but still was only available for the rich. And then this is 1950. This is a B-scooter. And the B-scooter was designed for Spain, because after the Second World War, Spain was incredibly poor, there was nothing here, and there was a need for mobility. However, mobility needed to be formed with the scarcity of materials. So there's this really little light car. The amazing thing about these three cars is that they were all Voisins. So Gabriel Voisin was an engineer who was able to understand new context and therefore design something completely different than before. The car itself, just a few of the engineering features. So there's a little propeller here. You can hardly see it because it's an all picture, obviously. So that's driven by the wind, and that's for the cooling fluid. And it also looks like if the car has no rear wheels. And that's because the rear wheels are really close together. Because if wheels are really close together, you don't need the differential in between that regulates the different speeds of wheels in the corner. And weight is of course hugely important for an airplane builder. So cars of Voisin are full of these little features that make car lighter than others. However, we're now in the 1930s, so this is Ford's River Rouge plant near Detroit. And then you can already see how big the car industry is becoming. This is not the romantic of one guy on the street corner who builds his own car. This is big. So Ford even had their own hoogovens. What's the English word? Anyone? So there's boats here with metal ore, and they're changing that into metal sheets themselves. So it was a full plant with everything. Now Ford saw the car as a commodity product. Something that's just there to be used for transportation, and that would be the same for all. So that's why he came up with the T-Ford in the picture, and that's why he invented this famous manufacturing process, automized manufacturing process inspired by what he saw actually in the meat industry. On the left of this picture is Henry Ford, and on the right is André Citroën. And André Citroën was an admirer of Ford. That was really a little bit of a strange combination, a strange friendship, because Ford was an anti-Semite of the highest order, and André Citroën was a Jew from Amsterdam. Actually, his name was Citroen, which is the Dutch word for lemon, because his family sold lemons. But when he moved to France, he made it more posh into Citroën. André Citroën is not, as many people think, a great innovator. He was a businessman. He, for example, started his company by buying a patent of these kind of gears with this strange pattern in it that actually hooks into one another better than normal gears. And if you look closely, you may even recognize that's where the logo of Citroën comes from. So if he was not an innovator, then how Citroën got the Traction Avant, which was the first mass-produced car with front-wheel drive, and also the first mass-produced car with a self-carrying monocoque, a self-carrying structure, no longer a leather chassis on which the car is built. Car aficionados amongst you are thinking actually Lancia was the first one, that's true, but that was never produced in big numbers. So if he was not that innovative, where did this come from? And if he was not that innovative, where did the Citroën DS come from? Which is in both engineering and form and expression like the epitome of comfort. Well, because when Voisin went broke, his people went to work for Citroën. So, and what we can say is that from this car to this car, engineering was the main driver of innovation in cars. So I would call that period form follows technology. However, the competitor of the Citroën DS was this car. This is the Renault 16. And Renault 16 was designed for what in French is called le cadre. So it's not the director, it's not the people on work floor, but all the people in between. And it was really meant to drive to work during the week and go for the weekend with the family and all your stuff with the same car. So that's why this car was really innovative in terms of that you can change the interior of the car. You can fold the seats. Actually, in the first versions, you would even not fold them down, but up to the ceiling. And then put all kinds of stuff in there. And then Renault, of course, came with the Renault Espace that was even more flexible in its interior. It was basically inventing what we call the MPV, the multi-purpose vehicle. The Espace on this side of the ocean, the Chrysler Voyager on the other side. And Renault went on to invent new kinds of shapes of cars. So innovation moved from engineering to how a car is being used. We moved from form follows technology to form follows function. So back to today. Let's have a look at where innovation is today. So we've seen innovation from technology, engineering, technology to use. This is a rear view mirror of a car, and it also has sensors in there. That's a rain sensor, the most retarded invention of the last 20 years. Cars also have parking sensors these days. And this, for example, is a sensor in the grille for adaptive cruise control. And there's a problem with this, because unlike the previous two developments in innovation, electronics are no inspiration for a designer what a product should look like, because electronics are small and you can basically place them anywhere, and you can also place them in the car after the car is already built. So where designers no longer have an inspiration what the car should look like, also there's a strategic problem for the car company. After all, this conference is about competitive engineering, but electronics have a way different dynamic than car design. You know, a car design process takes about 4 years, and then we have the car in production 5 to 6. And with electronics, you have an idea today, you build a prototype on Friday, and you start testing on Monday. And then also you don't have to wait for the next generation of cars to build it in. You can just put it in the production line as it is now. So it's no means for a car company to compete with other car companies. If we look at how innovation in form developed, we also have sort of a problem, because all car companies started to build other kinds of cars. Crossovers, we call them. Crossover is the automotive word for I don't really know what I made. These are both BMWs, for example. BMW in 1972 had 4 different car bodies, and today they have 54 different car bodies. I Googled BMW models, so that doesn't really work. So these designers that no longer have an inspiration what their product should look like also have many more cars to compete with, because now all manufacturers are in all domains and all geographies. And you see that developed into all kinds of new looks, of new applications in car design. So first of all, we see these kind of totally meaningless forms arising everywhere. Forms that are very fashionable and are likely to age much faster than the car itself. Then we see things happening like here. There's these two faults in the side panel that are coming way too close. And first of all, by the lighting, you can see it doesn't really work. It's mathematically, perhaps modeling, almost impossible to get that right, something like that. Also, it's like we're just throwing all Gestalt principles overboard. And this designer thought it would be a really cool idea to have the rear view mirror like piercing. So the biggest innovation in car styling is that we are now able to order the roof of our car in a different color than the rest of the car. So that doesn't really work well. So now let's look at the future context for which we have to design, because I already explained that context is super important. First of all, we have economic crisis. The last one is, I think, 2.5 years ago. The next one is around the corner. Don't believe me if you don't want to. And actually, I recently read an interview with the president of the Dutch bank, and he said there will be more crises and they will be closer together than in the past. And I'm thinking, okay, but if you say that, why don't you see then that there's a pattern there, that those crises are not crises in their own right, but they're sort of a big thing happening. And I think the problem is our dogma that everybody's running after of economical growth. You listen to politicians and they talk about economical growth. If they talk about quality of life, they don't mean how many friends you have, they mean how much you can buy. And to be honest, I think most of us can carry half of our stuff out of our houses with actually having a less comfortable life. It's even worse than that, because the latest thing that you see arising everywhere in many countries are these buildings outside the city with garages that you can rent to store the shit that doesn't fit in your house. And that's a problem, because research has shown that since the Second World War, our material wealth has doubled, and our luck, our happiness has remained basically the same. So there's no direct connotation between what we own and how lucky we are. Products can give us moments of happiness, but they cannot make us happy. I'm assuming everybody knows Maslow's hierarchy of needs. And the idea of this hierarchy is that you don't start filling up a level if the level below is not being fulfilled yet. So we don't start looking for shelter if we don't have food and water yet, and we don't start looking for social connections if we don't have shelter yet. The highest level of this is self-actualization, enlightenment, if you will. Look around in this room and you know we're not there yet. And that's because next to this pyramid of needs, we've also created a pyramid of wants. And that's what all the focus is going to. That's where this economic growth is. That's where this dogma is. And because it's reversed, it's also insatiable. But now, and this is sort of good news, we no longer need the Club of Rome or Mandela and his friends or what's his name, that former American president, to tell us that the Earth can't handle this, because we are at a point where it's no longer an opinion, it's just mathematics. Our planet cannot handle the question, the asking that we have for materials and products. And this is where I think designers and engineers need to start to take more responsibility, because in the past we really didn't. I can look at so many products and the designer may say, I take responsibility for this, and I'm really thinking, really, how? So, if we look at future developments on product level, and then I'm looking at mobility, first of all, cars are of course becoming electric. This is, by the way, the first charging pole that I've seen that's really integrated in society. Milan, that is. And this is interesting, because if cars become electric, for the first time they start to share the same energy infrastructure as the built environment does, as architect does. So that relationship between vehicles and buildings is going to change. And that's also nice for architects, because unlike you, I think cars are way more interesting than architecture. So. The second big development is, of course, car sharing. This is an industrial problem because we'll need less cars, and that's not what the industry is built for. But it also means that cars are going to be connected. Connected with the infrastructure, connected with each other, and connected with destinations, charging points, and you name it. And then, of course, there's autonomous driving. I already spoke about the idiot-proof car, where we're slowly shifting responsibility from the driver to the car itself. To have one more look at our campus, we're working on this really hard with a number of faculties, and all of the roads I've colored on this aerial photograph of our university campus, we have permission from the government to do autonomous driving tests. So that includes part of the campus and actually also one road up there that's outside the campus. And this is something that a number of faculties are working on or with. Because if we work with car manufacturers, they really like the theory, they really like the theoretical models and the mock-ups. But at some point they say, yes, but now let's try it in real. Can you do actual testing? And then, so if cars are going to do more and more of the work for us, and we're going to be less involved, if cars are basically going to be cyber-physical systems, I'm thinking of this famous poem of Heathcote Williams, who basically says, if aliens were looking at our planet, they will probably conclude that cars are the primary life form, and people are the fuel that they need to get the cars driving. All these developments that I just mentioned have one thing in common. In none of these developments, the car can be seen in its own right as an isolated object. It's all embedded. So we actually, in this timeline, need a third level. We need the level of system. Every product is part of a system which fits into the context. The negative side of that, I thought it was a really cool picture because all the presentations I've seen in this conference had graphs and all that, so now I also have a graph. But to be honest, all the automobility conferences I've been to in the last few years are so incredibly boring. And that's because it's all about passenger flows, it's about space, it's about energy use, it's all about rationality. Automobilism is rationalizing. And therein lies a problem. So this is probably the most rational car that we know. There's no emotion involved in the design of this car. On the other hand, the Americans spent $25 billion to park it on the moon, so that's maybe less rational, but still. So, if we travel back for a second to that Moskvich design team, you see that next to me is Alexander Kuyigin. And when I worked there for a while, one day he gave me a photograph and he asked me if I knew what car that was. And I didn't. I'd never seen it before. And what he told me, this was a car when he was younger he designed and built himself to participate in races through the Russian deserts for self-built cars. And that really amazed me because a communist regime is a totalitarian regime, and the most important mechanism to maintain a regime like that is that you take out all individuality of your citizens. And this is about individuality. And I'm thinking, for me, this is sort of proof that, okay, if even in a regime like that, it's possible to have self-built cars for races for self-built cars in the desert, that means there's a very strong relationship, emotional relationship between us and cars. Cars are really amazing products in that sense. You don't go to birthday parties where everybody is really upset or really obsessed with refrigerators or whatever. So the problem with this rationalizing automobility is that the car industry is not rational at all. This whole industry is built on brand identities, on emotion, on irrationality. It's all about emotion, basically. And that's a problem because it's also a very powerful industry. 1 out of every 7 German workers is in one way or another dependent of the car industry. So if you start designing new mobility from rationality alone, ignore the irrationality on which this industry is built upon, I think you're missing out. I think you're not accelerating but decelerating the rationalization process. So, and if we look at these pictures then, so basically on context level we have the collective needs, and on product level we have the individual wants. So here are the expensive cars, or individual cars, and here are the mobility systems that bring everybody from A to B as cheap and efficient as possible. And you need that connection in order to design. But with rationality, or the system in between, suddenly individualism is, the individual wants are no longer attended to. Suddenly we're looking at only the collective needs, which is where the rational is. So what I'm trying to do in Delft is embrace holistic design. I don't think it's any longer possible to design cars or many other products in their own right, isolated. You need to design them as part of a system. So last year I did the first tryout with a bunch of bachelor students and had them design not cars from start, but first a mobility system, quite abstract, and then each of the students in the team had to design one of the vehicles, one of the mobility means within that mobility system. And in research with this new plan, trying to strategize the move from automotive design to people in transit, I'm always also involving a lot of researchers, and they're sort of obligate to connect their own research to the other levels. So it doesn't matter if you're investigating comfort on this level of car seats or human behavior in that level, each investigation, each research has to be embedded in the whole picture. Because that's how you make connections and that's how you actually create a holistic environment in a research environment. And that was actually quite rapid. So I think that's my main message, and I think I'm well within the time.
Yeah. Just one.
I'm done.
Are you done?
Yeah, I can do it together.
Thank you very much, Dr. Elmer, for your very nice, funny presentation.
Thank you.
We have time for whatever question you can make, so please. Any over there?
First of all, thank you very much. It's a very interesting presentation. But just in relation to modern design, crossovers, and the number of car bodies and so on that are currently on the market, from a layman's point of view, is it not because of aerodynamics, fuel consumption, and wind tunnels that are actually informing the shape of cars that we're now looking at in the modern market?
No, the biggest development in this growth of kind of car bodies is basically SUVs, which are the high, big Jeep-like cars, and their aerodynamic performance is always lower than that of what we consider like to be a normal passenger car. So aerodynamics comes in the design process at some point, but it's certainly not leading.
And then, in so far as you were talking about, going from economic crisis to economic crisis. Again, the impression that one would get is that the manufacturers are collaborating together, and they are, even though they have different badges, if you like, but certain parts are all coming from a generic place where they're just assembling. Is that correct in terms of wings and doors and handles and even interiors?
Body panels in some cases, actually it's not working together, it's very often being owned by the same company. Volkswagen owns, I think, like 11 brands in total, 4 of which are like volume brands. So Audi, Volkswagen, Seat and Skoda are all basically the same cars with only different bodies and some minor tweaks. So there is a lot of working together, but it's because they are owned. So that's where the strategic design comes in, because if you don't do that properly, those brands will compete with each other rather than with brands of the other company. But you know, we've seen so many mergers and everything over the last decades. When I was a child, I could easily name like 70 car companies. I think there's now like 7, and they all have a whole portfolio of brands. So.
Thank you. Please.
You have been rather explicit on the transformation of the product over the last 50 years, for example, using the example of cars. Can you be a little bit more precise on how the design process actually changed? Do you think that the design process has less changes than actually the product which is designed during the process has experienced, or what is your opinion about that? How do we design it? How will, for example, the computer will have advantages or disadvantages when it's introduced as a tool in the design process?
That's the problem. The design process did not change at all since the 1930s. We start with sketches, then we go to scale models, then we go to full-scale models in clay. So actually the entrance of computers and nerves modeling, we have new tools. But the process in its like decision making and in its argumentation is not really changed. Now you see the first signs of, for example, last year talking to Guy Donkerwolke, who is the new design head from Hyundai and Kia. And he was the first time that a designer spoke about what he called an intellectual designer. And he literally said, you know, we always had intellectual designers, but they were on the side, while all the others were running for the next cool car. And now we need the intellectual designer in the center process. Chris Bengel, formerly director of BMW Design, says something similar. So now we first see the notion in the car industry that they no longer can deal with only like sketching cool cars, and that's the whole process.
But what I just saw in the former presentation was a future spamming again, Americanized future spamming, and flying cars, and I don't know, submersible cars, and you're saying it's much more inclined towards mobility and transportation. So the essence of having a car is probably diminishing, evaporating, but the mindset is still that we need cars. You know what I mean? Like, so every time we are told, even by the former speaker, that the next thing is that you have an individualized flying car, which I don't believe, because that's not a future, because we're all living in cityscapes. So,
well, you know, if ever you would, that's just laws of nature. A flying car costs more energy than a driving car. So everybody a flying car for me is not taking responsibility as a designer. It's the opposite.
yeah.
So and of course you can make it really efficient, but laws of nature only go so far, and then that's the energy that you cost. So flying cars may be useful somewhere in Australia or some really desolated area at some point in time. But for our urban environments, like Western Europe, I don't believe in flying cars.
No.
And let alone, most look outside, most drivers already have problems with 2 dimensions. Don't give them a third one.
Yeah, but I mean, now I see all kinds of vacuum cleaners on the street, like you call them electric cars. But I mean, that's the same sort of nonsense, right? It's continuous, it's the same, only with a different engine set.
Well, it's an improvement. I mean, a fuel car, I think of all of the energy you put in there, about 12% is actually used to move the car, and with an electric car that's close to 27%. But of course, that's still not enough. So
what is your future then in that sense? I'm wondering.
Oh, my future is what I tell my students. All my students in the future will drive really small electric cars,
Right.
and I will still drive my 1975 fuel car.
We have a question over here. Oh, please, Elmer.
There is some observation from me, namely that system thinking is getting very, very important in order to understand the current situations. And when you are talking about, for instance, your skepticism concerning flying cars, I fully agree with you, because the physics is there, and obviously it will be always higher level of energy taking the car, taking the weight of something, when there is a direct reaction opportunity which is taking the weight. The same if you are thinking about horizontally, that what is the issue, for instance, with the current, from system perspective, what is the issue with the current transportation solution? That it is discretized. Every entity is a separate, every car, if you like, is a separate entity, and for this reason they have to be taken care of. Now, why I'm saying it? Consider a train. A train is moving from the discrete towards the continuous. This is why a train as such is more efficient than 20 separate coaches or something like this. Obviously, the control is solved partially, because actually the control need is reduced to one dimension, the forwarding control. The other control is actually almost provided physically by the rails. This is interesting. So now the question is, for me, if I go into this system-oriented thinking, then the future is some sort of continuous transportation. Continuous transportation, which already can be seen, the tunnel. You know that these capsules in tunnel, which are trying to reproduce what is with the trains actually. So they can be automated, like in this sort of phantom trains in Frankfurt, which, or the metro in Budapest, which is driving already without driver, and this sort of thing. So when we are thinking about the future of transportation, I believe we have to leave behind the old paradigm, because it will hold us back. And then we say that here the problem is that the past was discretized and we have to go towards the continuous. That is the solution. What is your opinion about it? Can you believe that actually not the electrification of the car is the major issue, but having new paradigms which are moving us from the discrete transfer of people to a continuous transfer of people?
No, I think you're right in that new paradigm, but I'm not sure I believe that current generations are able to embrace a new paradigm. I think new generations to come, or just arriving, are much more likely to embrace that new paradigm. So there's going to be a really, really long transition. At the same time, it's also about how you design things. For example, the autonomous car is going to take people away from the train, because why would you sit in the train with your laptop when you can also do that in your own car that goes from door to door? So the design of everything is super important. Is that an answer? Or?
It is, but still my thinking is about what you said about the context, because that part of your presentation I really believe that was very relevant. So why we are not able to come up front with a new paradigm? Just for the reason because the past paradigms coexist with the emerging new paradigm. In this sense, the context remained there for longer than needed. In this, to be specific, what I believe is interesting here, that sort of context which is represented by the current infrastructure, that blocks the development towards a new world. Because if the current infrastructure was built up for discretized transfer, you will not be able to use it for tunnel transfer, which would be a new paradigm. So this is where I believe that when you said that the context determines a lot, it is really true in this context that What can we do with the current infrastructure when we are talking about fastly charging the car or battery replacement of electric cars? The old infrastructure is blocking us. When we are talking about even flying cars or whatever, the old infrastructure is blocking us.
But that's all physical context also. But there's also the context of interaction with products that give meaning to products, and that's much more complicated, I think, even to handle it. So you need to design something that people actually want to use. And not only that's more efficient, or that's what I mean by my argument about that in order to accelerate rationalization of mobility, you need to embrace the irrationality of it.
Mm-hmm.
Because if you discard it, I think it will only go slower.
We have a new question over here. I'm so sorry.
I'm not sure I answered already because I look at Elmer's face and he's okay.
I want to bring up something which is less technical, less from engineering. So a car is a product, but it's not just a functional product, it's a social product. No, you want a car because it gives you a social status symbol.
Absolutely.
And I mean, owning a car has a social function. It's not just a transportation means. It says who I am. Right? Now this is changing because from a product it becomes just a service, and that's a different way to look at it. So I was wondering how the car companies are reacting to this change of the meaning of the product.
I think not yet. I think they're still holding on to the past, if you like. A few companies, Renault, BMW, are a little bit more strategically, and if you look at what they did in the last 10 years, you see they're sort of refocusing towards a different future. But many car companies are still holding on to old values and that's not only a choice. That's, you know, if you build a car factory, you need to build at least 3 generations of cars there, which is 15 years before you've had a return on investment of building that factory. So it's not like that nobody realizes things have to change, but it's not possible to do it quicker. But I don't see a lot of signs yet. In design, yes. In strategy also, that things should be different, but you don't see that yet in the output of the companies. Because they're, you know, reinventing yourself in terms of looking at design as a holistic thing rather than just being obsessed with your own product. That's a big step. Realizing that, you know, it's a push industry. So altogether, these car companies maybe, I don't know, they produce like 100 million cars a year. And then at the end of the year, they're really surprised that there's still 5 million cars in the parking lot. Well, that 100 million is going to be 10 million if we share cars, if we don't own cars anymore. So that's a transformation that makes the Renaissance look small, I think. So I wish I had all the answers. I would be really...
Please.
I have a question which brings back the slide where you had this timeline to 2030, 2050. I'm wondering, since we develop theories for everything, not only for structural mechanics and thermodynamics, in terms of your professional experience in designing, do you see a potential mathematization of the art of designing towards a science using formalisms, or what is your personal opinion about this? Because, for example, in biology we thought it is such a complex systems. Nowadays we have systems biology, and we found systems of partial differential equations describing almost every aspect of the physical body.
Well, car design, as I know it, is largely a tacit knowledge. To put it simple, you sketch something and it's right or wrong and you don't really know why. So what I'm trying to do with these management models that I'm developing is I don't try to make design scientific, but I'm trying to frame that tacit knowledge with science. I know there are also scientists who think it can be scientific design. I get really nervous if I hear that. That's just, I think you can frame tacit knowledge. I don't think you can replace it. Is that an answer?
Yeah, I mean, I'm sure that an opinion of an experienced designer is a worthwhile statement. Because, for example, Michelangelo also doesn't have a partial differential equation verifying that the sculpture he was sculpting is the true and unique solution. So maybe...
yeah, but there's very few designers who have such a stature that they'll be believed on their word if they say something's really cool. That's why that framing of tacit knowledge is really about deepening the argument about form, deepening the argument. You know, if you make a sketch and your boss says, let's do that, he basically says, let's throw $500 million at that sketch. So you need more arguments than it's really cool to get that done.
Thank you. Any other? Or there, and then here.
What I found interesting in your talk was the reference to the Russian market. And your title was also Racing Across the Russian Desert. Could you maybe elaborate a little bit more on that? Because I was fascinated by especially the design of it, but also on the idea of racing across the desert. So, and what role does it play in your speech, in your talk? What is the...
For me, the fact that in a totalitarian regime,
yeah,
which is basically designed to make you not being an individual, that in that regime you still have people self-building cars and racing through deserts, that says something about the strength of what was suggested by a few people already, and by me, that cars are not a mere rational transport product, that we have a sort of special connection with it, which is about adventure and exploration, and so that's why I think it's a nice example. I think it's one of the extremest examples of our relationship, our emotional relationship with cars.
right, okay. Yeah, you cannot hear all the feedback in this particular area.
Yeah, because that's why you said there, because you start your own university, you said.
Correct.
So.
Well, I was told to do that.
Yeah, by you.
Yeah.
Okay.
Here we have.
I was very curious to know your opinion about the smart cars. Why it was not successful?
Well, you know, Hayek's idea was to make a really small, affordable car for in the city. But when he started looking for partners, a few car companies bailed out, and finally he ended up with Mercedes. And Mercedes is not a company that's able to build really cheap cars. So it's very simple. It was way too expensive. It was more expensive than a lot of cars with 4 seats and 4 doors. So why would you have it? So it became sort of this hairdressers and pizza delivery car instead of a car that was affordable as intended originally.
Do you think that that is the only reason? I don't think so.
Well, I'm convinced it's not about the design, at least not of the first generation. I think that was, you know, it's much harder to design a really small car than to design a Lamborghini or whatever big. So I think the first generation of Smart looks amazing. I think that can be the reason. So also it was very smart in terms of manufacturing. I mean, it should have been more cheaper. I mean,
There are also social issues. Imagine a family with 2 children in mountain, or people who want to take their friends with somewhere. There's so much limitation in those small cars. That's why I think it is not really realistic to think that in the future people will only have a car for individualistic way of living.
there's truth in that, but later Toyota came with the IQ, which has 3.5 seats, and it has the same footprint as a Smart, and that also did not become a huge success. So.
Those are the reasons.
complicated.
Economically, the rate is not successful. Yes.
That's also a thing, you know, the difference between a big car and a small car is 100 kilograms of steel, but in terms of complexity and manufacturing processes, so it's almost the same. So building small cars is really, really difficult.
Please.
Yeah, just coming back to the project that you gave your students in terms of designing the transportation for people in transit as opposed to individual means of transport. And I'm just wondering, from that generation's point of view, how many of them came up with a kind of a mass means of transport or transport high numbers of people, and how many of your students actually still went back to looking at cars as a means of transport? And I suppose where I'm coming from is that generation still influenced by the marketing? Because at the end of the day, the car business is a big business. It's a corporate world and it's corporate driven. There's too much money to be lost. There's too many jobs to be lost if the car industry suddenly came to a stop. So I'm just wondering, is the generation that's coming up behind us, are they as passionate by cars, or are they more sensible and rational about the means of getting to and from work?
That's a really difficult question. Well, there is, you know, sharing instead of owning is not only for cars, but for many products something that young generations, new generations are interested in. They are more interested in the effect rather than owning the means to get that effect. I have no idea if, you know, the petrolhead students that we get, often it comes from their parents or from their family. I do this little test every now and then. I show a scene from the movie Gone in 60 Seconds, which is about thieving cars, stealing cars. And there's this one scene where the thief walks through his building along all the cars that he stole. You know, they have this shopping list. And I'm asking students to write down the cars they recognize. There's Ferraris, there are Bentleys, De Tomasos, whatever. And that exercise since a few years is almost useless because they don't get any of them. Where like maybe 8 years ago, the best students would have at least half of the cars or a third of the cars. So that tells me something. But that's not really scientific evidence. But.
Please.
I would like to ask you if these ideas are focused on Europe or in Asia. Because in Asia, the manufacturers are focused on growing up manufacturing for all those amount of people who needs a car. And do you think these ideas could figure with the Asian customers?
Well, you know, most countries are now working on legislation that will forbid fuel-driven cars. So countries like Paris and Germany, from 2040, like they won't allow cars with a petrol engine to be sold. India is thinking 2030 already. If the Chinese think it's a good idea, it will be tomorrow afternoon. So I think they're actually moving much faster than we. Especially China, which is of course not really a democracy. It's much easier for them to make these that's maybe one of the few advantages of a regime like that they are able to make these transitions much quicker. And if you look at Chinese car companies, there are many, and many of them do electric cars. I was in Beijing last year, and they drove me around in only electric cars. So I always get a bit cranky if people talk about emerging economies, because they are not emerging. They've emerged and they're taking over.
So we are done, really? Okay, thank you very much again, Dr. Elmer, for your presentation.